Hello again everyone, day 15 with Rust. Let's check out how that will go. What are we looking at? We're looking at sensors and beacons. And each sensor has a corresponding closest beacon, which means from this sort of input we can build this sort of map. If we are looking at this sensor, and the closest beacon to it is really this one, then we're sure that anything covered in the map currently, well, there cannot be any other beacons. That's it. Our job is to figure out within a particular Y value of the map, how many positions are really taken already. And you very quickly realize that if you are asked about why that is 20 million, there's probably, this map is completely huge. So it doesn't really make sense to build this sort of map in memory, because, well, it's not gonna be feasible in the long run. Alright, how do we do this? This time around I've learned how Rust modules work and how they are used usually, so I've tried to use them correctly. Okay, so what I did is we have the main function where we pretty much just trigger the functions from day 15 module. In day 15 module, there's actually only 2 public functions and tests for them. That's it. I've decided to move any sort of reading of the input and any sort of creating of the map into the module that is called input. So within input, we've got a public function called readInput. And it uses private functions, readInputLine, getLength between points, and so on. And as always, we've got some tests. And I'm actually getting used to the idea that the tests are really in the same place or in the same file that the module itself. It's kind of cool because you can test out all the private functions this way. So yeah, interesting approach. I like it. As you can clearly see, I'm using a domain model which consists mainly of a sensor and a beacon. The sensor contains its coordinates and also the closest beacon. And right away I'm calculating length to closest beacon, because that is something that will be calculated over and over and over again, so it does make sense to have this. And lately I've learned that we can actually use self in here, because this is an actual implementation of the new function, so it's sort of a constructor here. So instead of returning the sensor, we could return self, and I think that should work. Yes, it does. Cool. We could probably go this way, so have a length to closest beacon. Now everything should blow up. Yes, it does. Okay, that's good actually. And then provide us with another function, which would be getting that length. It will work on self, and it will return the integer. Okay, that makes a lot of sense actually. So here now, we would go sensor, and then get length to beacon. I'm learning stuff. So perhaps this way, and let's go once again cargo test. Okay, cool, that's it. Let's try one more thing. So could we do that? Yeah, so we cannot add this field, which makes sense because it's private. So we cannot really build a sensor this way. That is very cool. That's exactly what I want. Okay, cool. I'm very happy with that. Okay. So what else do we have in here? As I mentioned, we're reading pretty much the input line and the input in whole. And what's kind of interesting is the length between points. So this is something that is called a Manhattan distance, yeah. Alright, so it's a Manhattan distance. So usually how we would measure distance would be a square root of sum of powers of 2 of specific differences in x and differences in y. But the Manhattan distance is really calculated as x difference plus y difference. So it's not really a circle, as you could see, it's more of a diamond, and that's the whole difference. What else do we have? We've got a map. Yeah, I'm using, as you can see, getLength to point when one of the points is a sensor, so it's only using that function that we saw a few moments ago. Alright, what we have here is position occupied, which probably should be called is position covered. You know what? Let's rename that. Cool. Yeah, now it reflects a little bit better, so it is position covered by one of the sensors. Okay, this is specifically for part 2, so we'll get back to it shortly. And here we've got some tests as usual. Let's go into day 15. And day 15 is the actual meat of the solution. First part was really, we were calculating the positions occupied or the positions covered, which were not beacons. And this is important difference. For line number 10 in the example, there were 26 positions where beacon cannot be present. It's not only the beacon cannot be present, so it's not only covered, but it's not a beacon. So how do we do that? Well, we read the map, then we get the map size, so we can go from, well, minimum x to maximum x. Then we're filtering any position that actually is a beacon. Then we map this thing, because we need to figure out, is the position already covered by any of the sensors? And then easy peasy, we just filter out whatever is actually occupied. And I realize now that this is a little bit more clear to be read. Let's double check if it still works. Yes, it does. Okay, cool. So this is clearer, at least for me, to read. And yeah, that's it. That's the whole thing. Part 2. And part 2 part 2 is a bit different. So it turns out that those sensors are actually covering pretty much all the map. And there's only one specific place where there could be a beacon that the sensors cannot see or cannot sense. There is the distress beacon. And once we find its coordinates, x and y, our job is to, well, calculate it, which is kind of simple. So you go x multiplied by 4 million and adding y on top of it. Since we were looking at y equals to 2 million, you can probably guess that it's the minimum size of the map, right? So if you have 2 million times 2 million, or even 4 million times 4 millions, it's huge. We cannot go point by point until we find the specific point that is not covered. Like, it's impossible. So we have to find another solution. For a specific y, we are getting ranges of x. How do we do that? It's quite simple, actually. So once again, the length, the Manhattan distance, was calculated as difference of y plus difference of x. We can easily calculate how much distance we've got left for x coordinate in case of this sensor. And once we figure this out, we just calculate the range this way. So this function actually returns already ordered ranges. Usually when you have a range, they will just overlap, right? And if they overlap, it's also quite easy to find when there is this very specific space in between, especially since we already sorted the ranges by the very first value. And this is done in here. After all, when we are sure of our coordinates, we just use this calculation as it was, well, asked from us. Can we run the whole thing? Yes, let's run it. Here we go, here's the output. Try to imagine if this is such a huge number, how much calculation we would have to do when we would be covering all the map, right? Impossible. Thank you very much, guys. I'm very happy you've been here. I'm happy I've been writing Rust. It's growing on me day by day, and what can I say? I love it. As you can see, I am very clearly using the functional approach when I'm trying to figure out things. But still, I'm a little unsure about, for example, borrowing, so I need to learn more, for sure. Thank you very much. Have fun, have a good day, bye everyone. And as always, we can do better as a pack. Bye!